So for the supervised learning, we have a few more methods, but we just want to look at how unsupervised learning is different. So we can proceed or continue with the classification based on other methods after we cover the clustering analysis, just to give you an idea. Okay, can you see the slide change to the second page or still on the first page?
It's changing, Prof.
Okay. So today we will look into the Waze clustering task, which is different from the classification task. So here we define the group based on the characteristic of the individual item. So we group items that have similar characteristic or similar values, and we separate those items which has different characteristics. So this is very important for those people who are in marketing or financial, because they can use this one for customer segmentation in order to do focus marketing or targeted marketing. So this is called unsupervised because we do not have any label to guide us how to classify them or how to model them, but instead we look at the content of individual item that we have. So this is based on the distance. We use a distance method to find similarity or how they are different from each other, depending on the content of each item that we have. So here, clustering is guided by the principle that record inside the cluster should be very similar to each other in terms of the values that they hold, and should be different from those outside the cluster. Sometimes we have one or two items that are totally out of the cluster, and this is called outlier. So outlier is just a noise. This can be ignored or can be eliminated, or this can be applied for detecting abnormal pattern in your data. So outlier play important role as well. So in the marketing, they used to find clustering method to do customer segmentation. So this is based on demography or buying pattern or targeted marketing campaign. And they also look at the history of purchasing behavior. So based on this, they can optimize their resources to increase the profit. At the same time, also clustering can be used to detect anomalous behavior. For example, if we have outlier refer to any point in your data set that does not belong to the clusters. So they are not normal. And this can be used to detect like unauthorized intrusion into computer network by identifying pattern of use falling outside known cluster. So this is called outlier. And at the same time also, we can use cluster to simplify your data set by reducing the number of features that we have into one. And this one column is called the cluster ID. For example, if you cluster your data that has 10 features, instead of using 10 features, we are using the one column that represent the cluster ID. So this also will simplify your large data set. Okay, so what is cluster analysis? So cluster analysis is basically looking at your cluster and then how do you optimize the performance of your clustering result. So the aim is to have a very compact cluster, so which means we minimize the intra-cluster, the distance between the member itself. And at the same time, we want to make sure they are located far away from each other. So each cluster will be separated far away from each other. So the further they are, the better is your cluster. Okay, so if we compare these two clusters, the left one is better because they are more compact, and they are there is a gap or there is a space in between them that we can say that separate the three clusters that we have. Compared to the one on your right hand side, they are not very compact, and the edge of the cluster is almost touching each other. Okay, so your right hand side is not a very good or not a very optimum clustering result that we should have. So based on this, how many clusters can we have here? 2 clusters, 6 clusters, 4. Any guess?
I think 6.
Yeah, we can say 6, but to confirm this, we need to have some benchmarking on how we're going to measure that one. So at the end of this lecture, we will learn how to measure the quality of the clustering result that we have. So we could say 2 cluster or 6 cluster or 4 cluster. But to confirm which one is better, we need to compute the compactness of the cluster and at the same time to measure the distance between the cluster that we have. So by doing that, we can verify which one is the best one. Okay. So for the clustering, we have hierarchical, partitional, and density based. So the latest one is called density based, and we do have hierarchical, partitional. So for the partitional, this is a division data object into non-overlapping. Non-overlapping means one item belong to one cluster only. So this is the traditional partitional clustering. We also have the hierarchical clustering in which the item can be viewed as a dendrogram. So dendrogram is a tree that you can look from the top to see the item belong to which cluster, depending on where you cut across the dendrogram. I will show you later on. Density-based clustering is based on the density. So you group them or form a cluster based on the density. Okay. So for example, this is partitional clustering. So they do not have any overlapping. This is hierarchical. So if you look at here, each item can be grouped to become one cluster. So for example, like this is considered one cluster. But if you group them, they become one cluster here. And then if you group these three, it becomes one cluster here. So from the top, you see that this cluster contains 3 items, okay, which is this one. Okay. So to have 2 clusters, we just got across here. For example, 2 cluster is here. If you want to have 3 clusters, then we need to cross across here, 3 clusters. Okay. So this is hierarchical clustering in which the item can be viewed as dendrogram. So we will be able to tell the clustering result just by cutting across the dendrogram that we have here. And the third one is called density based, in which we are looking at we will form the cluster if the criteria for the density is enough to form the cluster that we have. So this is a very good clustering result because we can form the cluster if we have different density, different size, or different shape. So this is the latest one. Okay. So we go for the first one. So this is the most basic one, just to give you the idea how do we perform the partitional clustering. So the first thing that we need to do is we need to find the center. So for example, if you want to have k number of clustering, for example, k equal to 3, so that means we will form a 3 cluster result. So what is the basic algorithm? Okay, given k equal to 3, we will randomly pick the center of your cluster. So the center of the cluster could be one of the member in your dataset. So basically, we pick randomly 3 records in your dataset to be the center. So from the k center, we will assign the remaining of the dataset to the nearest center. Okay, once we have grouping them, we recompute the centroid of each cluster, because once you group them, you will have different center already, depending on the average of the value in that same cluster that we have. So we will repeat them until there is no changes of centroid position. Okay. So the centroid, when we recompute them here, is basically the mean of the point in the cluster. That means we will take the average of all the vector values that we have to the take the average and consider that one as your centroid. So from that, we will measure the distance again for the rest of the data set to the centroid of your cluster. Okay. So for example, if we have this is your original point, this is your sub-optimal clustering. No, this is optimal, this is sub. So sub means the clustering result given, but not at the optimal condition. And this is happening because, as we mentioned just now, the center or the centroid are selected randomly. So it depends on your initial seed of your cluster. It will give you the clustering result if there are no changes of centroid. Okay. Okay, let's suppose we have this 3 cluster, but what happens is that your data, all of this will have no color. So we pick the centroid here randomly, okay, and then we assign the rest of the member to the nearest centroid. For example, this one is the nearest is to this centroid. The nearest of this to this centroid, and this one is nearest to this. So once we have formed this cluster, then we need to recompute the centroid. So for example, for this one, the new centroid might be here because that is the center. Okay, so across the time, you will see the centroid is moving to the right position or to the optimal position. So for example, we start with this, then we can see the centroid of the cluster going to the right position. Okay, so we need 6 iterations, 6 rounds. So if we apply this one in document, for example, we have 7 documents, and we need to form 2 clusters. So what happened in the first stage is that we select 2 centroid randomly from our dataset. So let's assume we have selected document 3 and document 6. So document 3 and document 6 will be the centroid. So our task is to determine this document 1 belong to or nearer to center 1 or center 2. Okay, so we can use the Euclidean distance, which is the square root of the summation of the differences. So for example, for this one, for document 1 and document 3, the distance can be computed by looking at the differences of this. So 3 minus 1, take the square, plus 4 minus 2, take the square, 5 minus 5, take the square, and then 1 minus 3, take the square. We add up all this value, take the square root, we get this 3.64. Okay, so we repeat again for document 6. So 3 minus 6, 4 minus 8, 5 minus 5, 1 minus 2. Take the sum, square root, we get 5.10. And it looks like that document 1 is nearer to document 3. So we put them in the same cluster. We repeat again for document 2. Document 2 nearer to this document 3, so we put them in the same cluster of document 3. And of course, the next one will be this, but since this is actually the centroid, so document 3 will be still inside here. And the next one we do document 4. Document 4 belong to center 2. Document 5 belong to center 1. And lastly, document 7 belong to cluster 1. So once we have this cluster result, so this is the end of iteration 1. So before we start with the next iteration, we need to find the new centroid. How do we find the new centroid? We group all the member of cluster 1 and cluster 2, then we find the average of these values. So we divide by 3. 3 to 1 is 6, 7 plus 6 is 13. So we divide by 5, similar to this. And divide by 5, and finally we get this. For the second cluster, we have 2 member only. So this is 6, this is 8.5, this is 4.5, this is 2. So that is the new center. Okay. So we continue with iteration number 2. We start with this center, then we look at whether they're nearer to center 1 or center 2. Okay, to measure the compactness of the cluster, we look at the sum of square. So this is the distance between all the member of the cluster to the center of the cluster. So basically this one is sum of square error. So sum of square error, that means we are looking at the differences and then take the square and take the sum. And this one will include all the cluster that we have. So for example, if we have these 3 clusters, so we will measure the compactness of this. So how do we find that one? First, we need to find the centroid for all these 3. Okay. So we just check the average between the values here. Then we get the center for all these 3 clusters. So once we get the center, then we compute the distance of document 1 to the center and also document 2 to the center. So for using the formula that we have, which is the sum of square error that we have, will be the for document 1 to the center 1. So this is minus that 1.5, 4 minus 2.5, 1.5, 5 minus 5, 0, 1 minus 1.5, 0.055, and then 3, we get 0. So we take the square and sum up the value here. We will do the same for document number 2. Then we get 2.75. So the value will be 5.5. So this is only for cluster 1. So for cluster 2, we will repeat the same. We will use the centroid. We compute the distance between document 3 to the centroid and document 4 to the centroid, and we add up this value together, we get 52.5. And lastly, we do for document clustering 3, we take this as the center. We use the sum of square error. So this is for the document 5 to the centroid, document 6 to the centroid, and document 7 to the centroid. We add up the value together, we get this. Okay. So to find the overall error, we need to add up all this value. Yeah, all this value. For this one is 56.68. So this is from the first cluster, second cluster, and the third cluster we have. This is the total sum of square error. So our aim is to have a very compact cluster. So the lower the value, the better it is. But this sum of square error does not count the separation between cluster, how far the cluster are separated. Okay, so that one we need to look at the Davis Boolean index. So another benchmarking that we can use. Okay. So this is the example of suboptimal, in which we will not get the optimum value. So this is what we get, because this is happening because the centroid of the cluster are selected randomly. So we cannot control this one. So to solve the problem, we need to run a few times, and we pick the one that give us the lowest sum square error. Okay. But they said, given your data set and you want to find the best clustering result, so they give you the formula here, where given K is your if there are K real cluster, then because we don't know what is K here. So what is the probability of us to get if K equal to 10 the best result, given the size of your data is this one, n times K. So this is the size of your cluster. So n times K. So n times K will be the number of data that you have. So they said for us to get, if K equal to 10, to get the best one is around 0.00036, 0.00036. So very hard for us to get the best one. But we should run our clustering method a few times to ensure that we have at least few choices to give us some overview what is the clustering results that we have, the compactness of our cluster. Okay, so consider this one. This is for the 10 cluster example. So we pick K equal to 10. So for us to find the best cluster is good for this one. But given another random selection for the centroid, we will not have a good one for this one. Okay. So in other words, every time we run our clustering result, we will get different centroid, and thus we will get different result for the clustering. And that's why we need to pick the one that gives us the smallest error to indicate that we have good quality of clustering result. So that's why I mentioned just now, how do we solve the problem of initial centroid? We can run our method few times, okay? Or we could use sampling or use hierarchical clustering. So this one will tell you which item will be combined, and then we can cut across the dendrogram to see how many cluster we need. So hierarchical clustering can be used to determine what is the best K. Okay. We could also select more than K initial centroid and then select among this initial centroid the best one. Okay. So the one that very time consuming is that, remember, when before we start with the next iteration, we need to update the center. So this center calculation is very time consuming. For example, if we have data 10 million, so we need to compute the distance between the centroid to each record 10,000 times. So this is very time consuming. Okay. So the problem with this K-means is that whenever we have different size, density, and non-globular shape, we will not be able to get the best result here. So what happened here, this is the original point. We may have something like this, so which is not what us expected. We also, if we have different density like this one, we're supposed to have 3 clusters, but we end up like this. Or if we have non-globular like this, then we could have this one. So not a very good clustering result. So for K-means, to solve this problem, we just have to add more centroid. For example, like this is for K-means. So our solution is to use many cluster, okay, and for different density also, and also for the non-globular. Okay, so to solve this problem, they have introduced DB-scan, which is the density based. So we will look into this one also. So we will look into that one in the next lecture. Okay. So any questions so far? So this is just to give you an overview. I think you have some idea about the clustering. Okay, now we go to another benchmark in which how do we validate our clustering. Okay. So for the supervised clustering classification, we can use accuracy. But for the cluster analysis, we look at how good is the clustering result. So the purpose of evaluating them is to avoid finding pattern in noise, because sometimes there is one or more records that can affect the performance of the clustering method because they will stretch the compactness of your cluster if they are far away. Okay, and also it will affect the distance between two clusters. Okay, based on the centroid. Okay. We can also use this benchmarking to compare which clustering algorithm is good. So that's why it is good to know how do we actually measure the quality of the cluster that we have. We could also use this one to compare two sets of cluster. For example, we have k equal to 3, but when we run them separately, we will get different clustering result. So we can compare two sets of cluster. Okay, or we can compare two clusters. So which cluster is better, cluster A or cluster B? Okay. So to look at the cluster validity, we have a few methods here. The first one is called external index. External index, they look at the characteristic of the data set itself, the behavior of individual item that we have in that particular group. So, for example, if you want to group your student into 3 groups based on the color scheme. So if you have one cluster having 10 students, but one of the students is color student, means black student. So that means you have one abnormal member of your cluster. Okay. So for the external index, we look at the label inside your cluster. Compared to internal index, they look at the structure of your cluster. So it is based on compactness and how far they are separated. So we can use the sum of square error that we gone through just now, but that one is only for compactness. So we will look into Davis-Bouldin index again, in which this one is based on the compactness and at the same time also the distance between the centroid of the clusters. Okay. We also have another one, relative index, but this one is just applying what we have in external and internal index, where we can combine them to look at the structure of your cluster and also the content of your cluster. So basically this is based on the content, this is based on the structure of your cluster. Okay. So let's take a look at the first one, which is based on the content. So they say that if your cluster have 7 content, that means the purity is high. So entropy can be used to measure the quality of your cluster, because the entropy looking at the purity of your cluster. So the cluster entropy here is defined by the sum of all the entropy that we have for each of the cluster that we have, and this is what we call the weightage. So each cluster will have the weightage depending on the number of members you have in that particular cluster. So this is what we call the entropy of the cluster. So since we have 1 up to k cluster, so we will add up all the entropy for all your cluster. Okay. So this entropy is defined by looking at this formula, in which this is the probability that an object randomly chosen from the K cluster belong to the S class. So the S class means they belong to certain label. Okay, log base 2, and then take also the probability of object randomly chosen from the K cluster. Okay? So this one is looking at the class label that you have in your cluster. So if you have two labels, that means you have two paths here. If you have three labels, that means you have three paths. Okay, so let's take a look at this example. We have three clusters here, and we can look at the label of each of the cluster. So for example, like this. Okay, so the formula for the overall entropy is given here, but the entropy for individual cluster is basically this one. So for cluster 1, we have 5A and 2B. So that means we have two paths that we have to look at here, because we are going from A to B here. Okay? So for the entropy for cluster 1, basically we have two paths. Okay, so we have two paths here. So the first one here referring to A, and then the second part refer to the B. Okay, so we take the value here. So this is only for the cluster 1. For cluster 2, so we have 1A, 1B, and 7C. So we will have three paths. So this is for the A, this is for the B, and this is for the C. Okay, and then the third cluster here we have 4C, 1A, 2B. So this is for the A, for the B, and for the C. Okay, so of course we have some value here, so you need to compute. So once we get that one, we plug in here, and at the same time we look at the weightage here. So this is the weightage. So this is the number of member that you have in that particular cluster. So this one we have 7, this one we have 9, and this one we have 7. So the first cluster you have 7 over 23, which is the overall total, 9 over 23, and 7 over 23. So this is the formulation for the looking at the purity of content of your cluster here. Okay. Any question? Okay. So this is based on the cluster entropy. So based on the cluster entropy, we look at how the result of the clustering can be assessed based on the content, based on the label, or based on the certain guideline or certain grades that we can use to measure whether they are similar or not. So we are looking at the content of your data only. So the second one is called internal measure. So this is a bit different from the external measure, because this one is looking at the structure. So when we talk about the structure of the cluster, we are talking about the compactness and also about the distance between the cluster. Okay, so the one who created this one is they call themselves as two person, Davis and Bouldin. So they call it DBI, Davis Bouldin Index, that take into consideration the compactness of the cluster and also the distance between two clusters. Okay, so the compactness of two clusters. So this is two different clusters. There must be two different clusters, and then we divide by the distance between these two clusters. Okay, so if we remember in the earlier slide, we mentioned that the compactness of two clusters, the smaller they are, the better. So this one is to minimize here, and the distance between two clusters, we need to maximize, right? So this one is to maximize. So when you have this formula, our task is to minimize the value. So we will go from cluster 1 up to C. Okay. So some of the formula which are important here is that how do we find the centroid? So basically we are looking at this is the distance to the center. So we have the distance to the center. So this is your centroid. So for every member in your cluster, you want to find the distance and then take the average. And this one is the distance between two centroid. This is how to find your centroid. We sum up all the value and then that belong to that cluster, and we divide by the number of items in that particular cluster. Okay, so how do we actually apply this one? Okay, so our aim is to minimize the intra-cluster and maximize the inter-cluster. So given this example, so we have three clusters, okay? Cluster 1, cluster 2, and cluster 3. So each cluster have three members, and each member has XY. So XY is just the features that they have. You may have different number of features here. So you could have 10 or 100 features representing each member in your cluster. But to make it easier to understand, we just have it X and Y. Okay. Okay, so the first thing that we need to do is we need to find the centroid. So how do we find the centroid? We take the average of each of these and we can get the centroid for each of the cluster. So we add up all this value, divide by 3, and we get the centroid. Okay, so that is the first thing we need to know. Where is the centroid of your cluster? Okay, so from here you can compute the compactness of your cluster, and at the same time also you can compute the distance between two clusters. So centroid is important. We need to find the centroid first. Okay, so once we get the centroid, then okay, now we can compute the distance between the cluster. Okay, so this is your centroid. Okay, for us to find the distance between C1 and C2 is just basically applying the Euclidean distance, which is 1.83 minus 3.5, take the square, plus 2.83 minus 0.67, take the square, and then sum up all together and take the square root. Okay, so this is the formula here. Then we get 2.73. So this number represents the distance between cluster 1 and cluster 2. So you have 2.73 here, and we repeat the same for cluster 1 and 3. This is 4.36. And last one is 5.49. Okay. So that is the distance between cluster. So now, next, what we want to do is we want to find the compactness. Okay, so we will use again the center here, and then for each of the record that we have in our cluster, we will find the distance and then take the average. Okay, so for the first one, we take the square root of the sum of the square differences. So this one is basically the first record. So 2 minus 1.83 plus 3 minus 2.83 square. Then you take this square root, and then you repeat again for the second item and the third item. Then you divide them into 3. You take the average. So that is the compactness. So basically the compactness refers to the average distance of all your members to the centroid. So the answer that you get here is 0.61. So this is 0.61. So you repeat again for cluster 2. So cluster 2, we have the centroid, and then we find 0.43. And lastly, our cluster 3, we have 0.66. Okay. So we have everything already. So we have the compactness of all the cluster. We have the distance between cluster. So now we will apply the formula. How do we apply the formula here? So this is our formula, right? So we will go from cluster 1 up to 3. So we have 3 clusters here. So this is, so basically we will take the average. Okay, so we will start from 1 to 3. Okay, so the blue one, so we start from here. So this is your, consider your anchor. So what we want to do is, you look at this formula. So that means we are running for all the other clusters. So we do this one first, and then we do that one. Okay, so let's do between C1 and C2. So this is between C1 and C2. Okay, so C1 and C2, we get the compactness of C1 and C2 and divide by the distance. We have all these calculated values already. So we just plug in, we get 0.38. Okay, now we do again C1 to C3. Okay, so now C1 to C3. So we get the compactness of cluster 1 and plus compactness of cluster 3 divided by the distance between cluster 1 and 3. We get 0.29. Okay, so the formula here that we want to find the value for different cluster, but we take the maximum one. So we have this and this. We take the maximum because we want to take the worst scenario, not the best scenario. Okay, so the worst scenario here is this one, because the overall mission is to minimize, right? So since we want to take the worst scenario here, because that describes what is the worst scenario. At the same time, we want to minimize. So for this one, we will take the 0.38. Okay, 0.38. Okay, now we have completed C1. Now we move to C2. So C2 will do the same here. So they will do 2 times, and then we compute this value, and then we will pick the one that give you worst scenario, which is this one. So for C2, we have this 0.3n. Okay, next one we will do C3. So C3 for C3 and C1, we have 0.29. C3 and C2, we have 0.2. So we pick this one, worst scenario. Okay. So once we have this 0.29, so the total dBi will be the summation of all this value divided by 3. Okay. So we add up all those value divided by 3. So we get 0.35. So this number is the dBi values. So if we have another clustering result and we get 0.3 or 0.29, this is the total here. Okay, so this is better than this. Okay, so walaupun we look at the maximum, because for individual cluster too, we are looking at the worst scenario. Tapi when we add up all this value already, so the total here indicate how good is your clustering result based on worst scenario. So if you rerun again, you get, for example, 0.29. That is better than 0.35. Okay. Any question? Yes.
Prof,
Yes.
okay, let's say we have 2 scenario lah. One using 3 cluster, and then the other one use 5 cluster. And then
Okay.
dBi ini can we use dBi value to compare which cluster yang better tak?
Yeah,
The number of cluster.
So for 3 and 5, you can use dBi because dBi measure sum of square, and no, dBi include compactness and the distance between cluster. Okay.
So so dBi yang the lowest yang better lah kan, the best number of cluster.
The lowest dBi is good.
Okay, Prof.
Tapi if you talk about sum of square, okay, if you do two cluster and then you break into 5 cluster and you break into 7 cluster, can you anticipate what is the value for the sum of square? When you have bigger number of cluster, what happened to your sum of square?
It is smaller.
It's getting smaller and smaller and smaller. But does that means that you have good cluster if you have more number of cluster?
Yeah, because the calculation pun kena affect.
Yeah. So that means if let's suppose you have 3 and 5 and 7 cluster, kan? So when you go to this direction, your sum square error ni, of course dia akan menurun, kan?
Yeah.
Because if you go back to the previous one, contoh yang ni lah. So this one, of course, you will have smaller sum of square, right? Compared to this, from 3 to 10, from 3 cluster to 10. Okay. So that means for sum of square, you only can use that one to see the compactness of your cluster, but you cannot say that, okay, 10 cluster is better than 3. because they are looking into the sum. They are looking into the compactness only, but not the distance between the nila. Right?
Prof.
Yes.
So meaning kalau we stick with the same number of cluster and then we compare algorithm using DBI, okay kan?
Yes.
Okay.
So DBI, they look into the compactness and also the distance between cluster. Okay. Any question? This clustering is very interesting because you can apply in many area, especially when you want to do your research. This is the main issue that they are looking into is this one. What is the value of K? K. What is K? And also, where is the initial center for K? What is the best seed of K? So this is for the partitional clustering. But to solve this one, they say, okay, I will use my hierarchical clustering. Because hierarchical clustering, you can have any number of cluster by just cutting across the dendrogram, right? Like this one. So for this one, okay, if I want to have 2 cluster, I have this. Okay, 3 cluster, I have this. 4 cluster, I have this. Okay, and there is no issue of center of where is the center, because to find the center, for example, to find the center for these 2 cluster, so this is the center for the first cluster. So to find the center for the second cluster is just take the average of the value here. Okay? Yeah. But the way they form the clustering is from bottom going up. So what happens is that they will join the point where is the nearest one, and then the merge. Then they keep merging and so on until you find one cluster here. Okay. So hierarchical clustering can solve the problem of finding the best number of cluster, and also where is the where is the centroid of each of the cluster that we have. So similar to this, if you want to measure, the quality of this and having 2 cluster or 3 cluster, we can use DBI also. Okay. Any question? Okay, let's take a look at the one of the example for the R software that we can apply. For example, like this practice where we have the location of the bike station. Okay, our objective is to cluster them so that we know where is the for example, if we have so many bike station, we want to build a service for the bike. So we want to find where is the if we divide them into zone or cluster. So of course, each zone or cluster, we can build the service bike station at the center of that particular zone. Okay, so in this example, we just gone to this one just to look at how we can use clustering to solve the problem. Okay. Okay, so for example, this one, we have this file, this data set. So it contains 2 columns, latitude and longitude. So we can also plot. So this one, we plot a histogram looking at one features of your station, and the color is gray. So this is the latitude, this is the longitude. If we plot them using the X and Y and using the same aspect ratio, this maintain an aspect ratio of 1:1, X and Y. So this is our distribution of our bike station. So if you want to define 2 clusters here, so maybe we can have the center here to be the bike service or repair station, or we can divide them into 5 zones. Okay, so we can set the seed to 1, 2, 3. Okay, this one is because in the clustering, k-means clustering, we randomly pick the center, right? So this is for the 2 cluster, 3 clusters. So we randomly pick the center. So to because sometimes we want to have the same center to fix them, so we can set them. So every time you run this clustering 2 or 3, you will get the same center, starting center. Okay. If you don't use this, then every time you run clustering 2, if you run them 10 times, you will get different result. Okay. So it depends on your requirement. You may need to fix, or you may not to fix this one. So for this one, we do the clustering just by calling the k-means, and then this is our data set, and we say what is our k. Okay. And if you look at the tree here, so this is our center, and this is the member of all individual record that we have. So that means record number 1 belong to cluster 3, record number 2 belong to cluster 3, record number okay, the first belong to cluster 3, second belong to cluster 3, and the third one belong to cluster 1. Okay, so this one is the compactness of the cluster. So sum of square by cluster. Okay. We also have this the size of each cluster, the center, where is the center? Okay, and we have some more here. So this is the total within the sum of squares. So basically the total of all this 1, 2, and 3. Okay, so we can have that one also. So okay, once we cluster them, this one only give you the cluster membership. For example, this 3 will give you all this number. So our objective is to combine this with our original data. So this is our original data. We will combine with the result of 2 cluster and 3 cluster. And when we look at our data, we will have like this. Okay. So initially they are separate result. So this is in the cluster 2, or this is in the 2, this is in the 3. Okay. So we combine them. So now our new data is this class. Okay. So now we want to plot them. So we want to plot based on the X and Y, and the color depending on the cluster ID, and the aspect ratio is maintained to 1. So that means scale X and Y is 1. So this is the symbol that we use. So this depends on cluster 1 and cluster 2 or cluster 3 here. And this is the main title, X title and Y title. Okay. And this is only to label all the cluster. We also need to label the center. So we highlight the center for those cluster, and the symbol that we use will be 23, which is this one. Okay, and the color will be the color line is maroon, background will be light blue. Okay. And we have the text. So depending on the center, so we will have the color of the text is blue, black, and we get something like this. Okay. Any question? Okay, let me go through. Okay, this is for the 3 cluster. Okay, let me go through this one. But let's have 10 cluster. So how do we actually get the 10 cluster? I need to stop. I need to share again. I share my screen. Okay. Okay, can you see my screen with the RStudio?
Did Prof?
Huh?
Oh, okay, sir.
Tidak?
Okay. Yeah.
Just lost it. Okay, so let me set the directory to my course file. Okay, so now I can read this one. And then I can do the the summary. Okay, so if we look at the head of my data here, which is the station, so head view. View. So this is my data here. Okay, so we have two latitude and longitude, and we have around 100 or 244 stations. Okay, so if I want to plot them, so this is my plotting. So this is my data here. Okay, so if I want to do 10 cluster, so I just get this one. Ten cluster, 10. So if we type 10, these are the member that we have. So 3, 5, 8, so on. Okay. So this is the center of your cluster. No, this is the sum of square, the compact. No, this is the what? Cluster sum of square. Yeah, this is the sum of square. So if you want to find the center, so we just type 10 and $sign and center. So this is the center of your 10 cluster that we have. Okay, and the total compactness of the cluster, we can check this one using the total within. So this is the total compactness of your cluster. Okay, so now I want to do the we want to combine with the data that we have. So we will do the column binding. So the column binding here will combine your station with your cluster 10. So this one is belong to 10, and we only have that one. Okay. So to look at your cluster, so we have this. Okay. So we have cluster 10 and so on. So next, we will plot them. So we'll be using all the symbol 1 up to 10. So for this one, okay, we do this. So class, longitude, color. So this is from the 10 cluster, aspect from the 10 cluster, or 10 kiosks. Okay. So you see the color of your cluster. So the symbol, the color is determined by the cluster ID, and at the same time also your symbol is determined by your cluster ID also. So now we want to find the center. So the center here, we plot the, so we are using 10, 10. Okay. and we have this. Okay. And this one will be used to number the so we will so we have a very nice view of the 10 cluster here with the center. Okay, so very interesting to play around with this, and then the next thing what we want to do is we want to find what are the common theme that they have for individual item, individual cluster we have here. So that is the next phase, which is analyzing the content of each of the cluster, why they are grouped into those particular cluster. But before we can go for that one, we need to be able to cluster them. Okay, any questions?
Prof,
Yes.
yang this dataset ni only consists of 2 feature kan ni?
Yes, but
Okay.
if you have more than 2, then you still will be able to cluster them, but you will be unable to visualize them because you have more than 3D still can, but 4D cannot imagine lah. But
Okay.
but you can view the quality. You just look at the compactness lah, compactness, and also the distance between cluster, and also you can analyze the content of individual item that we have.
Okay, Prof. And then another one kan, kalau we use dataset more than 2 feature, and then is it necessary kah to visualize the data, I mean the cluster, and then after we implement the PCA?
You can do that just to look at how it looks like. So what you do is just you compress them into 2 features, right? Using PCA.
Yeah.
Yeah, boleh. But
Oh.
in most cases, they want to go into the individual cluster and extract what are the characteristic of this cluster, why they are grouped, so that easier for them to do further action lah.
Meaning Prof, yang cluster tu they will look into dia punya value kah for each feature?
They will group all the individual record tu into cluster. Lepas tu untuk setiap cluster tu they want to know why that particular cluster is grouped in that cluster. So maybe for example they want to analyze student yang having chat ataupun status in Facebook kan. So they will cluster the student ataupun the user. So they will see, okay, this group always talk about music or heavy metal. The other group always talk about cake or ataupun party and so on. So you can basically group the individual based on their activity.
Okay, Prof.
Okay, so I share this file in the ITEL. I give you some time to run this one. So if you have any problem, you can call me. Okay, so I share in the ITEL.